Let's talk about one of the coolest Iceberg features, time travel. You can query your data as it existed at any point in the past. It's a very simple concept, very powerful in practice. Let's start with the basics. We've got this sales table, once more, that gets updated all day long. New sales coming in, corrections, adjustments, there's lots of activity in the business. That's a good thing. So let's walk through a day of transactions. There are 3 sales in the morning, 2 more after a little while. To us, this is a lot. Oops, the first sale has the wrong amount. It should have been 165, not 150. Time for an update. And sale ID 3, well, the customer changed their mind and asked for a refund. So we're just gonna delete that one. That's how we represent that refund. Okay, fine. It's not exactly a high volume business yet, but everybody starts somewhere. And every time you change a table, remember that Iceberg creates a snapshot, a record of the table's state at that moment in time. It's like Git commits for your data. It tracks what changed, when, and lets you go back in time to a previous snapshot if you need to. So for each change we make, Iceberg created a new snapshot. Iceberg actually tracks all snapshots in a special metadata table called the Snapshots table. There are several other metadata tables. We're going to cover them in a later module. But to see them here, we're going to query sales.snapshots. And again, check your actual engine docs for this. It could be like sales $ snapshots or something. These things are slightly non-standard and vary between engines. And here I'm just showing the key columns: when the snapshot was committed, the snapshot ID, and the operation that Iceberg thought this was. Was it append, overwrite, delete, or replace? You see we've got 2 appends, 1 overwrite, 1 delete. That's exactly what we just did. To time travel, we use the for system time as of clause and then give it a timestamp. And Iceberg finds the right snapshot before that time, the first snapshot before that timestamp, and then gives you a query according to what the data was at that time in that snapshot, that version of the data. So here we see right after the first insert, the return hasn't happened yet, the corrected sale amount hasn't happened yet. We have traveled back in time. Here we use a slightly later timestamp right after the second insert. We're going to be picking that second snapshot. I'm showing it there in that snapshots table, and you'll see in the results, you see additional sales. You can also query a specific snapshot ID if you happen to know it. If you're looking through the snapshot metadata table and you get that ID out instead of using a timestamp, that's just fine. You see the syntax right here. And this is right after we fixed the amount. We did the update to change the amount of the first sale. If you query without time travel, you always get the current state. You get the most recent snapshot, the now. This is just like a normal database would behave. Iceberg can also roll back to a previous state. If you want to undo that delete, you can roll back to before it happened. So use rollback to snapshot if you have the snapshot ID from the snapshot metadata table, or rollback to timestamp if you want to roll back to the first commit prior to the timestamp that you specify. In practice, you have to fully qualify the table name when calling Iceberg procedures. I'm not showing that here because I want the examples to fit on the slide. So if you literally try to type this in, you'll have to make some changes to have fully qualified table names there. What rollback does is it marks the old snapshot as the now current snapshot. So all future queries and writes will start from there, from that snapshot that you rolled back to. Let me show that again visually. After you roll back to snapshot 3, everything after it, like say poor snapshot 4 there, is out of the active timeline. You can still time travel to it, but you can't roll back to it anymore. Iceberg won't let you. That's not a roll back. That's a roll forward. If you make a change after the rollback, Iceberg starts a new lineage from there. That old history, snapshot 4, that stays disconnected. When you really need the nuclear option, like you just need to go somewhere in time and you don't want to worry about, is this a rollback or whatever, you can use set current snapshot. That's Iceberg's kind of look, I know what I'm doing, just go here, this is the right place to be, stop asking me questions, kind of maintenance operation. You can jump to any snapshot you want. You can go forward, backward, doesn't matter, no rollback checks, no guardrails, no parenting you. You just get to go where you tell it to go. This is another thing that is a sharp knife. You can, this way, create a big mess for yourself. So keep maybe your LinkedIn profile up to date. If you're going to do this a lot, there could be consequences. You want to be prepared. Let's look at some real world scenarios where time travel saves your bacon. So fast forward a month, business is booming, sales are flowing, everything's great. Then somebody runs a delete and they forget what a good thing predicates are. It's a delete and there's no where clause. There are consequences. So first, let's look at what we're dealing with. Maybe the data's still there and we're panicking over nothing. Okay, 92 rows. Oops, there should be 1 million. Customers are still actively buying stuff. These 92 sales have just rolled in, but we got truncated very recently. So we can't just roll back and nuke these 92 purchases that have happened since then. Nobody wants that CFO conversation about missing the records of Tuesday's revenue while we're trying to fix this problem. So no big deal. We can just query the table before the incident using system time as of. There they are. Okay, millions of rows all intact. The data's fine. We just can't see it in the current state. We can see it in this query, but it's not there if we're not specifying the system time. Here's what we're going to do. We're going to make a backup table and populate it with the historical data that we're getting from that time travel query. So the sales table still has new sales hitting it and being recorded. Everything's fine. Systems are up. History might be a little messed up, but new sales are being recorded. Now we're going back in time, grabbing the historical data before the delete and putting it into this backup table. Then we simply take that whole sales backup table, dump it into the sales table. Crisis averted with just a little bit of SQL. Weekend saved. Take a deep breath, relax. Time travel also shines for regulatory compliance, audit trails, even maybe some weird stakeholder questions about past reports. Sometimes you need to show auditors exactly what data looked like at a specific point in time. Say the sales revenue the company reported in October. You don't have to say, well, we think it was. And now you can actually go there and show the exact data at that time using Iceberg time travel. Last example here, and this is super interesting. I'll show you how powerful time travel can be. So it lets you detect changes between 2 points in time. So this query, joining the results of 2 separate time travel queries with different system time as of timestamps, is joining them and selecting only the rows that have different amounts. So remember, we changed that amount. Well, here we're able to go back in time and look, is there any point in time where sales amounts are different? And this query does exactly that. Really cool stuff that you would have had to design some kind of historical data system in your data lake. Your data architecture would have to build this in. Your ETL jobs would have to be thinking about this in order to be able to get this done. And now it's just a property of your data lake. Let's finish with some performance considerations. Time travel can be fast, but it's easy to shoot yourself in the foot. Let's not do that. First, let's make sure we've got where clauses and narrow time ranges when possible. If you could avoid scanning 6 months when you only need 6 days, it goes without saying, mind those predicates, especially when they've got timestamps in them. Second, partition pruning works with time travel. Those where clauses in your queries, those will help the engine skip files that you don't need. Third, maintain your tables. Regular compaction and snapshot expiration keep things tight and fast. So we're keeping a history of snapshots. We don't need to keep snapshots forever. In the module on table maintenance, we'll actually drill down into that with a little more detail. Number 4, use time travel carefully. It's great for debugging, it's perfect for audits, but for frequent operational queries, that might be the wrong tool. That might be a thing where you need to build in some kind of history into your data architecture itself so that you're not having to maintain old versions of data in the data plane itself. It might be a thing that you need to build into your schema and into your systems more broadly. Time travel in Iceberg really can change how you manage your data. You want to keep it focused on use cases like debugging, audits, and helping give you trust into what you're seeing historically. It might not be a replacement for every possible historical data use case. There might be some of that you have to build in. But man, is this feature great to have when you need it.